Here are the 4 techniques I will discuss in this module for defining project scope. The boundary between what's in and what's out for a specific product release or iteration. First, I'll describe the context diagram. The context diagram represents the system as a circle, with the name of the system inside the circle. Outside the circle, we see several rectangles, which represent things that are outside your system but somehow interface to it. And the nature of those interfaces are depicted in the form of arrows between the external entities and the system circle. One limitation of the context diagram is that it doesn't show any details about the system internals at all. The use case diagram is a complement to the context diagram. It shows connections between external actors outside the system and specific use cases or tasks those actors are going to perform. So the use case diagram, unlike the context diagram, does provide some visibility inside the system. Many project teams, particularly those that are building commercial products, talk about product features. Many features can be implemented in multiple levels of detail or enrichment. You might start out with a rudimentary implementation of a particular feature and then add more capabilities to it over time. This is a good way to think about release planning. You can determine which features will be implemented to what degree of detail in each upcoming product release. This gives you a feature roadmap, and you can describe the scope of each particular release in terms of the various feature levels you plan to implement in that release. The final technique for documenting project scope that I'm going to discuss is to identify the external events that could take place. The system needs to be able to detect each event and figure out how to handle it, based on detailed information associated with the event and the state of the system at the time it detects the event. These events could be things that happen in the world of the business, time-triggered events, or input signals received from some external hardware device or another software system. The first scope definition technique is the context diagram. This is not a new technique, having been developed in the 1970s, but despite being old, they are simple and useful on nearly every kind of project. The context diagram treats our system as a black box, or in this case, as a red circle. This is a partial context diagram for an actual project I once worked on when I was at Kodak, called the Chemical Tracking System. The name of the system appears inside the circle. We don't know anything at all about the system internals. That red circle represents the scope boundary, the interface between your system and the rest of the world. We also have objects shown in boxes outside the system, which are called terminators or external entities. External entities most often represent groups of users, such as chemists or people who work in the chemical stockroom. External entities could also represent organizations, like the Health and Safety Department, or the buyer who places orders with chemical vendors. They could represent other information systems or external databases. Specialized hardware devices that must interact with your system, such as a barcode reader in this case, are also shown as external entities on the context diagram. However, I don't include ordinary hardware devices such as printers or computer workstations. The interactions between the external entities and the system are shown with the arrows, which are called flows. Note that these are directional arrows, not just lines. They indicate inputs to the system or outputs from the system. So the context diagram consists of just one circle, some boxes, and some arrows. It's very simple, and all project stakeholders should be able to read a context diagram without difficulty. As an example, this diagram indicates that a chemist could submit vendor catalog queries to the system. Then the system performs some magic and sends some vendor catalog information out to the chemist. So the context diagram shows these kinds of dialogues taking place, obviously at a high level of abstraction. You're not going to show every detail of every piece of information the chemist might feed into the chemical tracking system, because then you'd have hundreds of arrows on the picture and that just becomes unmanageable. So this is a very high-level view of what the system does. The primary purpose of the context diagram is to show the environment into which your system fits. I can tell you a story about how a context diagram is used to have discussions regarding project scope. A few years ago, I was at a company teaching a requirements class. A woman in the class showed me a context diagram that she had used just the day before in a conversation with her manager. Let's imagine it was this context diagram on the slide, And the manager said, "Oh, we've decided that the training database is actually going to be part of the chemical tracking system, so that box belongs inside the circle, not outside the circle." What just happened to the scope of this woman's project? It got larger, didn't it? Initially, she thought the training database was going to be someone else's responsibility and she would just interface to it. Now she knows the training database is going to be part of the chemical tracking system that she's responsible for. This is a scope increase. So this diagram is a way to help the project stakeholders understand the critical scope boundary between what's inside the system and what lies outside. I recommend that you have different project stakeholders draw their own context diagrams and then put their heads together to look for similarities and differences. You'll almost certainly learn that no one person came up with a complete list of external entities. You'll probably also find differences in vocabulary and different interpretations of the scope boundary for the project. One person might group 3 related user classes into a single external entity box on the context diagram, whereas someone else shows them in 3 separate boxes. The context diagram is a useful tool for reaching a shared understanding about such issues. Here are some tips to keep in mind for drawing context diagrams. First, I don't normally draw connections between external entities, even if they exist, because then where do you stop? Sure, the chemist and the buyer might have some direct interaction, but if it doesn't involve the chemical tracking system somehow, then frankly, I don't care. It's not part of what we're going to build. If you start drawing all those connections, and everything's connected to something else, then pretty soon you've created a whole enterprise model, which is not the intent of the picture. Instead, use the context diagram to treat the system of interest at the center of the universe. One other guideline for the diagram is that the items on the flows should all be nouns or noun phrases. Don't put verbs or actions on the flows. Instead, the flows should represent data, control signals, or actual physical materials that move between the system and an external entity. Physical items could move between the system and an external if the system, as you've defined it, encompasses more than just a piece of software. The third point is that this is a communication tool, and the rule is that anything that aids and abets effective communication is good. Anything that inhibits effective communication is evil. So perhaps you say, "Oh, I don't like to use the circle and boxes. I like to put a triangle in the center and I use ovals for the externals." Well, that's fine, except that I don't know how to read your picture. So this inhibits effective communication. When you're using a context diagram or any other kind of analysis model, your team needs to agree on the notations you're all going to use and stick to those. I recommend using this convention because it's well established in the software literature and it's a very simple picture that anyone can understand.